Okay, so in this lecture, we're going to talk about networking and how multiplayer games work. We're going to try to understand the client-server model and also talk briefly about Unreal's replication system. So in a single-player game, there's only a single instance of the game running on a single machine. In a multiplayer game, multiple instances of the same game are running at the same time. So these can be different processes on the same machine. This is exactly what we had when we tested the game previously in the engine. When we set the number of players to 2, the engine instanced 2 games for us. So this is exactly that scenario. We had 2 instances of the game running on the same machine and they were connected to each other, so we were able to play a multiplayer game that way. You can also have different computers on the same local network. Let's say that you have a bunch of computers connected to the same Wi-Fi network or connected to the same router. You can actually play a multiplayer game through that network connection, and that is called LAN. And finally, you have players on different areas of the world playing over the internet. So the first scenario is a little bit rare. You usually don't want to, play a multiplayer game on the same machine. This is usually the case that you test the game. And you might have some people playing over a LAN connection, maybe some friends getting together, but usually you have people playing over the internet. And we're gonna learn how to do all of these things, all 3 that we're gonna do in this course, so fear not, you're gonna learn all of these. And the first 2, spoilers, is very easy. You already saw the first one a bit, but the difficult one is going to be playing over the internet. But like I said, we're also gonna learn that. So all these different instances of the game, they need to communicate with each other and build a consistent game world. Because if you think about it, all these connected machines, they need to share information with each other in order to have a consistent game world. Let's say that you have 3 different machines and they're all running an FPS game. So all these computers, all of them have their own version of the game running. And let's say that you're playing in this first one right here. You have your character, and let's say that you want to move your character to the left. Well, if you make the move, the other 2 machines, they don't know that you moved your character yet. So in their own version of the game, your character still didn't move. So your machine needs to let them know that you made a change. So over the network, you need to tell them, hey, my character moved, so update your game according to that. Because if you made a change to your game world and they didn't, that means that the gameplay experience is inconsistent across the different players, and that is obviously not a good thing. But there's a problem with this approach. This is usually called the peer-to-peer approach. You have clients, these are called clients, connected to each other directly and they're sharing information directly. But as you add more players to the game, in this case we have 3, this gets complicated real fast because all of the computers need to talk to every other computer and letting them know that there was a change. And likewise, all of these guys, they also have to talk to each other. So like I said, that gets complicated real fast. So that's not how it works in Unreal. Unreal uses what is called the client-server model. So on the client-server model, some machines are designated as clients and a single machine is designated as the server. And all the clients connect to that server, and the server has the authoritative version of the game world. What does that mean? That means that the only correct version of the game is on the server. The game is essentially being played on the server. All the clients are basically simulating an approximation of what is happening on the server. So when something changes on the server, on the real authoritative game, those changes are sent to the clients so that the clients can update their own version of the game to have a very close approximation of what is going on the server. And this process is called replication. So here you have the server, and the game is happening here, and all the clients are connected to the server, and the server sends them information about what is happening in the game. And this also fixes the problem that we had with the peer-to-peer model, because in this model, the clients are only talking with the server. They don't need to talk to each other. So the only connection is between the client and the server. So that complication that happens with increased number of players doesn't happen here because the server has the responsibility of updating the clients instead of the clients trying to tell every other client what they're doing. So I like to talk a little bit more about the fact that the server is authoritative. Because the server is authoritative, the clients can't make a change on their own. So let's take the example that we had just now. You're playing an FPS game, so this is an FPS game. You have 3 clients connected to the server, and you're playing on this first one. And you have your character, and you want to move your character. Well, you can't. You need to make a request to the server first. So you tell the server, hey, I want to move my character to this location. And the server looks at your request. Is this reasonable? Is this a valid move in the game? If it is, the server makes the move and then sends that move to all the connected clients, including you. So now all the clients have the updated information about the game world, about your character. You also have the updated information, and the server was able to check the move before it made it to make sure that it is a valid move. So anytime a client wants to make a change, they need to ask the server to make the change, and then the server, if it's a valid change, will make the change and replicate the change to all the other clients. To really understand this, I think thinking of these machines, computers, as chessboards really helps. So these are real chessboards, so not, a chess game running on a computer. So think of a real chessboard here. And imagine that you have a chessboard on your desk in your room and you're alone. And there's another player somewhere, the other client. They also have a chessboard on their desk in their room. And there's also a server somewhere, also with a chessboard. And let's say that you're playing here and you're playing as white, so you have the first move. You decide on a move and you want to make the move, but you can't because you have to ask the server. So you take your phone and you call the server and tell the server that you want to move your pawn 2 pieces ahead. The server looks at the move, it looks like a valid move, so the server makes the change to the chessboard and then calls the other client, telling them that the white moved their pawn to this tile. So the other client makes that change, and the server also calls you to make the same change. And now it's black's turn. Likewise, black decides on a move, calls the server makes the move, lets every other client know about the move so they can also update their chessboard. And this is basically how it works. We're going to talk a little bit more about the replication system. So Unreal's replication system is integrated in a way that abstracts the difficult parts of network programming. When you're doing network programming, you need to handle things like sending and receiving packets, managing connections, opening up sockets, and all sorts of things that you need to learn before you can really make something. Like I said, Unreal's replication system abstracts all that away from you so that you can easily develop a multiplayer networked game without having to deal with these things or think about these things. If you want a property like a variable to be replicated, you just set that to be replicated and Unreal will take care of the rest. This really makes things easy for us. Once you understand the basics of multiplayer and networking in Unreal, it's really not that much different to make a game in multiplayer compared to a single player game. You just need to do a little bit of upfront work and change the way you think, but after that it becomes much easier. So that's going to be it for this lecture. There was a lot of talking and explaining, but at this point in time I really want you to understand these concepts so that in the future, when we start implementing these in code, you're not going to get confused and you're going to have an easy time. So thank you for watching, and I'll see you in the next one.